So today's webinar is about how Cortex XDR Global Analytics protects against supply chain attacks. Myself, I'm Erez Levy. I'm a research group manager in Cortex XDR, protecting our digital way of life here at Palo Alto Networks for the last 5 years and in the industry for the last 15 years. I'm currently leading a group of security researchers that work day and night so that Palo Alto Networks customers are protected from new and creative techniques used by attackers, specifically focusing on techniques that are used by attackers in enterprise networks that are very difficult or impossible to detect in a context of a single device. Together with me today is Francisco. Francisco, do you want to present yourself?
Sure. Hi there, my name is Francisco Mois. I'm a customer success architect. I've been working for Palo Alto since 2016. I started as a professional services consultant, and really looking forward getting to know you in the future, hopefully. Thanks.
Thank you, Francisco. So what we'll talk about today. So first of all, this webinar is relevant for Pro and for Proper TV Cortex XDR customers. And supply chain attack protection is available since Cortex XDR version 3.3. This webinar is a bit different than most of previous webinars. Here we go deep and behind the scenes into how analytics work and how do we protect against supply chain attacks. First, we will have a deep dive into analytics, global analytics, and what are supply chain attacks. Afterwards, I will explain how do we harness the advanced capabilities of Cortex XDR agents and analytics into a protection methodology against supply chain attacks, as well as additional techniques that are used by attackers. Next slide, please. So first step, what is Cortex XDR Analytics? Before we explain what is Cortex XDR Analytics, let's first understand what problems does it try to solve. Prevention capabilities are needed to stop most of the attackers, but unfortunately, a dedicated attacker will eventually bypass prevention mechanisms. That's because an attacker can simulate attacks against the relevant prevention platform until it manages to overcome it. Click. That's why we need an alerting system like Cortex XDR Analytics. An attacker cannot simulate and model analytics. That's because all the logic runs in the cloud, and most importantly, the logic behaves differently on each and every customer. So if something behaves in some manner on a specific model tenant, it doesn't mean anything about the actual customer target. What it means is that when an attacker tries to simulate the attack, it's impossible for him to prepare for such an attack without getting detected. So we have a clear advantage of knowledge when we have access to everything and can profile whatever we see over a long period of time, and an attacker can never know what we know. So analytics is the advantage in these cases. That's something that we see on daily basis, both on red team activities that are conducted internally and as well as actual attacks on our customers. So even when device prevention is bypassed, analytics is very, very hard to bypass. Next slide, please. Okay, so now that we know why we need it, what is essentially Cortex XDR Analytics? So it's a highly scalable service that detects malicious activities that are based on various kind of data types that are collected from various sources and of different vendors. So here, for example, we can see a certain NDR, a certain customer that has various kinds of event collection capabilities, spanning from EDRs that can be Cortex agents or something else, NDRs that can be next generation firewalls by Palo Alto Network or something else, as well as additional data sources. This data is sent on a highly scalable XDR analytics cloud that's based on Google BigQuery and Go. And inside the cloud, the data is ingested in various ways. More on this later. But going through the analytics engine, we learn profiles and entities and raise analytics alerts that are based on the data that we learn from it. Yeah, we can move on to the next slide. Thank you. So we can imagine this as an enormous pipe of data of various types, sources and vendors. Here we have a very partial list that streams epic amounts of data. And this data that's streamed within the pipe comes from all of our customers. We'll look at this stream of data as if it were the matrix. And we produce highly valuable, otherwise impossible to deduct detections based on anything that we can learn by watching such a stream. Some examples would be which processes injected threads into which other processes, which endpoints communicated with which endpoints, when does each user work, what hours, what resources does it access, when, how much, and many, many other things. A bit about device detection versus analytics detection. So what can be prevented and detected on a device, or the device itself, is prevented and detected. This method has limitations in terms of visibility, device resources, compute, memory, latency, update frequency. And what cannot be prevented and detected on the device itself requires something else. So in our case, as mentioned, centralized, modern, agile, and highly scalable cloud. It's based on GCP, BigQuery, Go, Kubernetes. And the advantages of this method is being cross-device, cross-data source, cross-customer, and having cross-customer visibility. So we don't just see what a single device can see, whether it's an agent, a firewall, or something else, but we see what all agents see and all firewalls and all other types of devices, including the third-party vendors, from the entire organization, as well as from all organizations in our customer base. Cloud resources allow taking this cyber big data scheme into profiles, statistics, and machine learning. And together we get detection of otherwise undetectable attacks. On the next slide, we have an example of what we see on our infrastructure of a profile that we learn. And we have hundreds and hundreds of local and global profiles and roles profiling various activities on all data sources, whether it's from EDR, NDR, cloud, user, single sign-on. And here, for example, we can see which endpoints and which image names were used and what command line arguments were used for the entire tenant. And on this slide, we can see which entities, which could be an endpoint or an unmanaged device, which entities communicated using which remote ports, with various statistics that we learned about the communication between these entities. And this also an example for a profile that allows high fidelity detection with analytics. And we have many and many of those on various event types that we collect. So these are some examples. Okay, so moving on to the next slide, let's talk a bit more about the architecture and core concepts of analytics. So we divide this into 3 steps. First step is data fusion, which is done by what we call the data fusion engine, DFE. It is written mostly in Go. The second step is server-side detection, which is non-analytics detection. And the third step introduces machine learning and analytics into the mechanism. And this allows the analytics-based detections. Each event arrives into a stream, and it is then normalized, meaning events from different data sources or vendors are normalized into the same schema. That's the first step. Afterwards, the event is stitched, meaning we look at several events and stitch them together into an enriched and coherent story that contains the good of all worlds from all sources of data. Then we have a process that's called association. So we associate events into entities. We learn strong, unique identifiers of entities in the network, and we use what we learn to better track entities looking forward, like learning from DHCP packets, which MAC address was mapped into which IP address. These enriched events are then pushed into several server-side detection modules, matched for IOCs, behavioral IOCs, XQL BIOCs, and correlations that customers are then can freely add to the product. Afterwards, these enriched events are pushed into the analytics engine, in which profiles and roles are learned from them. And then we raise analytics detection alerts based on logic that takes these learned profiles and roles into account. In this way, we actually create very high fidelity detection. So this allows cross-vendor detection and real-time analytics. And it works on several supported detection content modules. UEBA, which is User Entity Behavior Analytics, NDR, EDR, Cloud, and more to follow. So going into analytics major building blocks. First up, the data fusion engine that is in charge of normalization, stitching, and association. Here we can see the same event arriving both from an agent and a firewall. Click, please. And in this case, the data fusion engine normalizes and stitches the data from both sources into one enriched story that has both agent operating system context as well as firewall DPI context, so that we can detect an attack based on the full story that we possess regarding the event. Next up, profiles. We learn statistical information based on the events that we see. Things like how popular in this domain for the customer, how popular is it for all customers, how common is this that calc.exe opens up another process or loads a certain DLL. Then on the next step, we assign roles to entities that we see in the network based on events that are visible to us. This entity, which can be an agent ID or a MAC address, is a DNS server or a domain controller. This user is a database administrator. This entity is a printing server. And we use these roles on the final step that is essentially detecting attacks. So based on the data that we learn on all of these three stages, can you click please, Renee? So we use all of this to build statistical models, and then we raise alerts in whichever domain, based on events and the statistical models that we built from that. And we can see ports that are rarely communicated between entities. or with a large deviation from a certain baseline that was learned. We can, for example, identify uncommon thread injections into processes, even on a global level, or unusual calls to certain operating system API functions in various processes. Okay, so I talked a bit about stitching. Why is it that crucial? So as can be seen in this example, we use both EDR context data as well as firewall DPI data, a process and Kerberos usernames profile, learning which processes communicating using which Kerberos usernames. Then, when a future event arrives, we join the event with this profile, and then we create a high fidelity analytics alert. This can be done because we learn both on the events and detect based on stitch data. So this requires that the stitching arrives at a very early stage. Otherwise, the learning mechanism, the profiles and the roles can't learn from the complete story. So a bit about the analytics engine, stream, and batch processing. So when XDR is turned on, the Fusion data engine takes the raw data and builds logs that XDR can work on. These logs are stored in a big table behind the scenes that has all the logs after normalization, stitching, and association. And the association happens in real time. So changes to the association tables are only forward-looking. When analytics is enabled, we learn up to 30 days back from the moment it was enabled. Roles and profiles are calculated immediately on all available data at this point. And after we finish batch processing for roles and profiles, we start creating analytics alerts in real time based on streaming data that's coming in right now. We recalculate the profiles every 24 hours, and we use the new profiles once those are ready. Okay, so here we have a few examples for detectors. We have about 1,000 detectors with various severity levels in various domains. You can look at these examples. There are also, all of the detectors are also available on documentation online, and you can read about them and get to know what kind of detections are available. Okay, so let's take this to the next step. What is Cortex XDR Global Analytics? So Global Analytics is a new and powerful capability that we added to Cortex XDR starting version 3.3. It takes the concept of analytics learning that takes place on a customer environment level, in which various baselines are learned specifically for each customer environment, and it extends it to the global level. What this means that if previously analytics was able to determine a baseline and detect anomalies in the customer's environment, now with global analytics, Cortex XDR is able to determine a baseline and detect anomalies on applications that are used on our customer base. So for example, if we take the previous profile that we looked at, in which we learned what command lines were used for each process image name in a certain customer's environment, now we also do it on our entire customer base in a normalized and pseudonymized manner. And we do it for all sorts of events. Let's say we do it for file hashes, for example, and WMI queries that are used, system calls, domains that are accessed, and many more. This learning mechanism takes place on normalized and pseudo-normalized data using sophisticated models and normalization techniques. And this capability is tremendous in terms of allowing us to detect global scale anomalies that could be part of an APT that's using exotic tools, as well as it allows us to improve existing detection methods and provide an even higher precision rate. Cortex XDR agents continuously collect vast amounts of highly granular internal operating system data. And we talked about the examples before. And these events are collected and they span process executions, modulars, networking, system calls, remote procedure calls, WMI queries, registry events, file, mount, injection, and many other types of events. These events are enriched with additional data that adds context from stack traces, file entropy information, ancestor process metadata, and others. And once all of this highly granular data continuously collected from a large enterprise customer base is pushed into a scalable analytics engine, we get well-trained models that learn how various applications behave. And the more data that we have, the better we can identify globally unusual behaviors in these applications, which can indicate malicious techniques that's being used. Okay, so we've talked about analytics, we've talked about global analytics. Let's talk about supply chain attacks. So what are supply chain attacks? In today's world, no company develops everything by itself. No matter which industry vertical we look at, from financial institutions, government, oil companies, nuclear reactors, military organizations, it doesn't matter. Everyone uses software or hardware that was developed by someone else, by third-party vendors. In doing so, every company essentially puts its trust in the protection not only of that third-party vendor, but also in every other company in that vendor's vendor list. It's recursive, essentially, a recursive chain of suppliers, and each one is susceptible to an attack. So this creates an opportunity for determined attackers, whether they come from cybercrime groups or they are nation-state sponsored attackers, to target the weakest link in such a chain in an effort to gain access to the attacker's primary target. A software-based supply chain attack is the case where an attacker, commonly a nation-state sponsored one, breaks into the systems of a software vendor and adds or modifies the code in a manner that would benefit the attacker. The benefit to the attacker is gaining access to all or some of that vendor's customers. This can be achieved with a minimal backdoor, a vulnerability that's only known to the attacker and will be used to attack that vendor's customers. Such supply chain attacks essentially seem like any other legitimate software update to a signed application. So what supply chain protection solutions are there? The prevalent one is cloud-native supply chain security, which consists of security products that are part of the DevSecOps approach, analyzing code and CI/CD scripts for configuration errors, known mistakes that are introduced by software and DevOps engineers, as well as usage of open source packages with known vulnerabilities. This is relevant only for companies that develop and sell software. An additional protection solution is post-breach supply chain attack protection. This is contrary to the first solution. This is relevant to all companies, not just software development vendors. Palo Alto Networks is the only cybersecurity company that offers such protection. And this can be detected by the inability of security products to detect the SolarWinds supply chain attack. Also, very few companies even have a starting chance of attempting at this kind to detect this kind of attacks using this kind of approach, as there's a very high bar of collection and ingestion capabilities that's required, as well as a very large customer base that you need in order to execute on such a protection mechanism implementation. So next step, how do we protect against supply chain attacks? And a clue about it is that we do it with global analytics. Okay, so application profiling, we've mentioned it before. Let's talk a bit more about it and how this works. We start by reducing the problem space into products and vendors that are viable and attractive targets for a supply chain attacker. These vendors and applications are divided into several verticals, and each vertical of viable supply chain attack vendors is learned across various EDR event types in our entire customer base. Nation-state actors, once they have a supply chain attack capability, will use it very carefully, like any other zero-day. So it won't be burned. Meaning that if the actor uses their capability to, let's say, encrypt all file systems within their reach, thanks to a supply chain attack, their capability will be lost the day after. Instead, only basic reconnaissance operations are executed on many endpoints, but only on a select few. The attack continues to the next stages, and that's exactly what we need. Cortex XDR essentially functions as a debugger that continuously runs on millions and millions of endpoints and collects highly granular operating system data. This data is globally profiled and then used to protect against supply chain attacks. For example, if a certain application, say a SolarWinds Orion agent, is installed on thousands of customers, we profile all sorts of event types that we collect on it. For example, we look at the WMI queries that it executes. Then we're able to see an anomaly in the sense that a certain type of WMI query was executed only on very few Orion instances. As we can see here on the example in the slide, we're querying the firewall product dataset, but we do it only on a single customer. So the same applies to domains that are accessed, system calls that are used, LDAP queries, and anything that we continuously collect. So why does it work? So here we have the reasons that we're able to do this so well. First is that we continuously collect tremendous amounts of data from endpoints. No other EDR vendor is even close to the amounts that we collect. Our data is of a very high operating system granularity level. We collect stack traces, shell codes, entropy, statistical information, system calls, PPI-based metadata. We have .NET hooks, and we have much more deep internal operating system information that we collect. We have a sophisticated kernel-based tracking mechanisms that allows us to track and enrich events into what we call malicious causality groups, making it difficult for an attacker to hide its actions. And then we're able to track anything that happens into what caused it to happen. Also, our enterprise customer base is very large, and that's exactly where actors that use supply chain attacks attack. They attack enterprise customers. And the last point is that our EDR analytics capabilities are more advanced and established than those of other vendors in the market. So essentially, you can be calm. Palo Alto's got your back. We've got next. You can find detections from the global analytics detectors, and you will see the name of the alerts. If you get those are very uncommon to get them. But we use global analytics for supply chain attack detection. But again, as mentioned before, we use it to detect other kinds of attacks, like DLL hijacking and exploits. And you can see the alerts from analytics, starting with globally uncommon behavior from a sign process. That's it for the slides for today. If you have any questions, any additional questions, please feel free to ask on the Q&A section, or you can raise your hand virtually, and I can let you ask.
So, Eres, there is a question in the Q&A. One of the slides you mentioned network story, and the participant is asking, is network stories referring to the preset option within SQL, or are we talking about something more specific to analytics?
Okay, so a network story, I think it is the network preset in SQL. Essentially, you can use SQL to query these network stories. A story is the event that comes out of the data fusion engine. It's the coherent story. It's like the event that was built from everything that we know on a network level. It's like the smartest event that we can build network-wise. And yes, it is. There's a preset for it, and you can query it using SQL. It's an event type. Another question that I see here. Sure. Is global analytics part of the standard XDR or XDR Pro purchase, or is it a new purchase point to be added to a license? So global analytics is part of standard XDR Pro and the Pro per TB. Another question that I see is, what's the best way to learn SQL? Okay. So best way to learn SQL is using documentation that there's online and can be used. And also, you can always reach out to customer success and the relevant SEs to get additional help and assistance. But there's documentation that can be used to improve the capabilities of using this tool. It is a very strong tool, so it does take time to master it. But once you do, you can do amazing things. These are all the questions that we've been asked so far. So I'll give maybe about half a minute to see if we have any additional questions. Seems that we don't. Renee, you want to take it from here?
I think we can finish the session for today. Thank you so much, everyone, for participating. Thank you, Erez. Thank you, Francisco, for being